Hi there. Recall that in Parabola, so far, we have learned its equation, which is given by x minus h squared equals 4p times y minus k if the parabola is oriented vertically, and y minus k squared equals 4p times x minus h if the parabola is oriented horizontally. Aside from this, we also learned about its parts. So given its graph, we know its focus, the vertex, the directrix, its major axis, as well as the latus rectum. In this video, given the equation of a parabola, let's try to find out its parts. So, our strategy would be, but first let's enlarge this one. So the strategy that we would have in this one is, first given an equation, we try to convert it into its vertex form if it is not already in it. Then from the vertex form, we know that in the last video, we can easily determine its orientation, whether it's vertical, horizontal, or upward, downward, or to the right or to the left. And given the orientation and the vertex form, we can also obtain its vertex, this point out here, as well as the focal distance or the p in the formula. Using this focal distance, we can obtain its focus. So we'll obtain that by adding p up and the directrix by adding p down. So it will look something like this out here. So we have the focus and the directrix given the focal distance. Aside from this, we can also obtain the latus rectum, this one, since its length is just equal to 4 times p. So given the focal distance, again, we can obtain the focus, the directrix, and the latus rectum. And lastly, given the focus and the vertex, we can obtain its major axis, since the major axis is a line that passes through the focus and the vertex. So now that we have a good grasp on how we'll attack and find these parts of the parabola, let's try out some examples. So starting with this first example, we have y equals x squared. Before we try this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So in here, first, since this is already in its vertex form, take note that we can find its orientation already. So since the square out here is in the x variable, and the constant beside y is positive, then we know that, in the last video, we know that the orientation of this parabola must be vertical and opening upward. So the graph would look something like this. Take note that learning the orientation and the graph, or having an idea in mind of how the graph looks, is important, since the orientation will be important since the location of the focus is dependent on this, as well as the directrix, and so are the other parts like the latus rectum and the major axis. It would depend on the orientation. So let's now try to find out its parts. First, we know that since this is already in the vertex form, to emphasize it more, we can write it in this form. So we have x minus 0 squared equals 4 times 1 over 4 times y minus 0. Now this looks more similar to the equation that we learned in parabolas. So first, clearly, the vertex is given by this 2. So it's the point 0, 0. Aside from this, we can obtain the focal distance. So it's just this one, since in the formula, this is represented by 4 times p out here. So the p out here is this one. So we have p equals 1/4. And given this focal distance, again, we can obtain the other parts of the graph. So to obtain the focus, we just move the vertex p distance up here. And to obtain the directrix, we just move p distance down here. So to do that, we need to shift this point up. So what we are changing here is the y component. So given the 0, 0, to move it up, we need to add in the y component out here. So we add the focal distance, which is 1/4. So adding 1/4, we'll obtain 0, 1 over 4. So this one represents the focus of the parabola. Again, this shows the importance of the orientation of the parabola, since we know that the focus is located inside the parabola. So knowing its orientation, we know that what we must do is add 1/4, or the focal distance p, and on the y component, since it's up out here from the vertex. To obtain the directrix, we do the same. So we just subtract 1/4, so it would look something like 0, negative 1/4. But since the directrix is a line, more specifically a horizontal line, so we know that horizontal lines are given by y equals some certain value. Since the y component out here is negative 1/4, we just put here negative 1. So we have this to be the directrix. So we now obtain the focus and the directrix. Next thing that we can obtain is the major axis. So the major axis is just a line that passes through the vertex and the focus. In this case, it must be a vertical line, since the focus and the vertex are aligned vertically. So it would be a line from this one. To determine what the equation of the line would be, take note that vertical lines are given by x equals some value. And since the x component of the focus here is 0, and the y component, or the x component of the vertex here rather, is also 0, we know that this must be 0 too, so that it would pass through these 2 points. So we have the major axis to be x equals 0. Lastly, for the latus rectum, or more specifically its distance, we simply note that to obtain the distance of the latus rectum, we just multiply p out here by 4. So 4 times 1 over 4 would give us 1. So the distance out here is 1 unit. If you want to learn its points, just take note that since it is in line with the focus, then the y component must be the same. And since this should be, that's correct. And then for the x component, since this is 1 unit, and we need to divide it, we just divide it by half. So we get the left side and the right side, since we know that these two distances are equal. So dividing 1 by 2 will have 1/2. So we have that this point is represented by negative 1/2, and this one is represented by 1. So these are the endpoints of the latus rectum, since again recall that the latus rectum is a line segment. Okay, good. So let's now move on to the next example. In here, again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let us try this one out. First, observe that the given is still not in its vertex form, so you can't really determine or find anything yet. So take note that, let's try to convert this first into its vertex form. So we start by moving negative 4x to the right. So we'll have y plus 2 squared equals 4x plus 8. Then from here we can factor out 4 in here to obtain y plus 2 squared equals 4 times x plus 2. And this one out here is already in its vertex form. Since the square out here is in the y variable, and the constant beside the linear variable, which is x in this case, is positive, then we know that the orientation of the parabola must be horizontal and opening to the right. So its graph would look something like this. So let's now try out to find its parts. Take note that y plus 2 out here can be written as y minus negative 2, and x plus 2 out here can, so we do the same, so it can be written as x minus negative 2. And so we know that the vertex is given by these two out here, so we have the point negative 2, negative 2. For the focus, this time, since we have, before we get the focus, I forgot the focal distance first. We can find the focal distance easily out here, since we know that this one is represented by 4p. So clearly the p out here is equal to 1. So we have the focal distance to be 1. And given this, let us now try to find out its focus and the directrix. Since the parabola this time is oriented horizontally, and we know that the focus is located inside this one. So what we do is we move this point 1 unit to the right. So what we do is we change its x component. So we add 1 out here, and that would give us the point negative 1, negative 2. So as you can see, it's really important to know the orientation of the parabola. Even if you don't have this drawing, though it's better if we have a drawing, knowing its orientation is still important to know where the focus is located, and as well as the directrix. For the directrix, so it's located out here, since it is outside the parabola. So again, we move the x component, so negative 2, we subtract 1 here, so we'll have here negative 3, negative 2. But since we're dealing with lines out here, more specifically in this case, it must be a vertical line. So vertical lines are given by, or of the form x equals a certain value. Since the x component out here is negative 3, then we know that this must be equal to x equals negative 3. So we have the directrix to be this. So we now have the focus and the directrix. The next thing to find is the major axis. In this case, the major axis is a horizontal line, since it must pass through focus and it must pass through the focus and the vertex. And in this case, the focus and the vertex are aligned horizontally. So to determine the line in this one, since it is a horizontal line, then it is given by y equals a certain value. The y component out here is negative 2 and negative 2. So for this line to pass through the vertex and the focus, we know that y equals, in here, the value in here must be equal to negative 2. So we have y equals negative 2 to be the major axis for this parabola. Lastly, for the latus rectum, take note that we just multiply p out here by 4, so its length is given by 4 units. So this one out here is the latus rectum. Again, to determine its endpoints, first take note that since it is aligned vertically in the focus, then we know that their x component must be the same. So we have here -1 and -1. For the y component, take note that the latus rectum out here is 4 units, so we divide that by 2. So we get 2 units. So since we know that this one is of equal distance, we just add 2 units up on the focus to get this. So -2 plus 2 out here would give us 0. And we subtract 2 units down. So -2 minus 2 out here would give us -4. So these are the endpoints of our latus rectum. And this out here is the answer for this problem. So I hope you got that one correctly, and by this time I hope that you now have a better understanding on how to get the parts of the parabola. So with that, here are 2 exercises that you can work on. So similar to what we had, your goal here is to determine the vertex, the focus, the directrix, the major axis, and the latus rectum, its distance, and its endpoints, given these 2 equations. So take note that these 2 equations are not really still in its vertex form. So that's the first thing that you need to do. And from there, determine the orientation, and it follows that you can find the parts of the parabola. The important thing to note here is that in finding the parts, it's really important that you understand how parabola works, where these parts are located, and why we add certain values to obtain these parts. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any solutions and answers for these exercises, as well as comments and suggestions for this video and this channel in general. So yeah, that's it, and that is all for this video.